Here's another Level 3 question from Exponent Properties. In this problem, I see a lot of fractions going on. But what I would like you to connect this problem to is the problem x to the 4th, y to the 5th, times x to the 3rd, y to the 9th. If I gave you this problem, you would simply tell me, oh, I'm going to add my x's together to get x to the 7th, and add my y's together to get y to the 14th. This problem is the exact same, I just have fractions instead of whole numbers. So I'm going to go ahead and look at my like bases. The first like base that I have is these are both 8s. So I'm going to go ahead and add their exponents together. Now the shortcut to adding fractions is to simply add the top numbers of each fraction and keep the bottom number the same. So the 8 is going to stay here. If I add the tops of these fractions, 2 plus -1 gives me 1. Then the bottom of my fraction is going to stay a 3. Now I'm going to go ahead and put my x's together in the same way. I take these two fractions and I add them together. So the x is still my base, but if I add the tops of these two fractions, 11 plus 5, that is 16, and the bottom stays the same. Lastly, I'm going to do this with my y's, adding up the fractions that are with them. So my y stays my base, add the tops of these two fractions, so 9 plus 6 gives me 15, and the 5 stays on the bottom. Now when I look at this answer, it's not quite as far simplified as it possibly can be. If I look at this 8 to the 1/3, there's no variable there, so I'm going to type that in my calculator using my exponent button. 8 to the 1/3 power is 2. Now when I look at my variable of x, I have a fraction up in my exponent. So I'm going to see if I can simplify that fraction. Well, 16 divided by 2 would be 8. So I could rewrite this as x to the 8th power. Similarly, with my y variable, if I have 15 divided by 5, I could make that y to the 3rd power. And this would be my final answer.